Personally, I've never reported an SQL injection bug to a bug bounty program. So I was that much more surprised to see that the sum of bounties awarded for them isn't really decreasing. I decided to do the case study and extract all the disclosed SQL injection reports from the internet to analyze them. In this video, I will show you the impact of SQL injection or how to escalate it to, for example, an RCE or a file write or simply what to read. I will also show you the charts of those reports and bounties per year. Enjoy! So for the impact, I have 7 different metrics here and we'll go through them one by one, and we'll start from the least common, which was file read or write. In this case, it was load file in MySQL. And I'm quite surprised that this is the only report with this impact, because I also, in the full case study, which is part of BBR Premium, I also did the breakdown of SQL engines, and MySQL, which is used in this report, is the most common one, but this was the only report. And it looked like this. You had the load file function, which just returned you the file. So really simple payload. Also, the hunter was quite lucky that the result of the query was included in the response. But nevertheless, really risky bug. And if you have an SQL injection in a MySQL application, definitely use the load file. And also, the hunter was able to write the data into any file, which possibly could be easily turned into an RCE. I can't judge by these headers what technology is being used here, but if this is like PHP or Java server pages or something like this, you can easily turn this into an RCE. So this is a really serious bug. So definitely make sure to test this if you have a MySQL target. The reason why this is the only one report with this, one of two probably. One is just people don't know about this function. The other, probably more likely, is that this is not enabled by default, this function, and developers just rarely use it. So that's what I would assume. But we'll go to the next class, which is authentication bypass. And I had 2 reports like this. One of them is here, and we have the case where the most basic SQL injection payload is being used to bypass the authentication. This very payload, I think is my first ever attack on a web application. When I was just learning web security, I think this is like one of the first labs I've done, so quite sentimental to me. And I wouldn't really expect this to be present in a real-world application, but apparently it is. You can also see that this write-up is quite originally styled, I would say, quite strange. There's also a interesting image, and the system was drunk or something is the takeaway. And when I do these case studies, I sometimes go through reports like this where I the truth is that I can never verify a report like this, because if someone says that the target is redacted, I just have to trust them. And sometimes I have write-ups like this where I look at them and I think, is this real? But in this case, the target is not redacted. It's an actual thing. It's Django REST framework. And I checked, it exists. It actually has 26,000 stars. And I even did go one step further, and I wanted to find the bug, because if it's open source, I can find the bug. And I didn't spend hours on it. I spent like 10-20 minutes on it, and I didn't see the bug. This framework, since the very beginning, uses Django's authenticate method. And as much as I could maybe believe a simple bug like this would be present in the not very common framework for Django, I really doubt, I'm pretty sure this bug didn't exist in Django's Authenticate method, which is probably one of the most commonly used in 2018. There are regularly SQL injections in Django, but they are not simple payloads. For example, I remember this one because it's the first ever patch I've reversed. We did a CTF task. It was in 2019, so the bug was already public, but the payloads weren't public at all. So I had to reverse the patch, and I remember it very clearly. And it was quite a complex bug with JSONs, with some nested properties, things like this. And it was 2019. And I'm pretty sure that in Django, it wasn't present in 2018. This write-up is from 2018. And also, the write-up here says that he found 10,000 orders and 800 users accounts and 800 employees accounts on the URL that's redacted here, but the URL in the beginning is not redacted, and it is the local host, which makes perfect sense. If you are testing a local application, it makes perfect sense that you test it locally, but then you don't access customer information, you don't access 10,000 orders unless these orders are yours. And also the hunter said here $2,000 of reward, which I don't know. Django now gets bounties from Internet Bug Bounty Program, which was founded in 2021. And I also Googled this person, their HackerOne profile. I think I have it here. And they actually are a real person with almost 5,000 reputation on HackerOne. So I think they started reporting real bugs after some time. But they are not on the leaderboard of Django or of Internet Bug Bounty. And I say Django because the website of this framework says that they handle security by Django security team. So that's why I'm looking at it. So the takeaway is that this write-up is I'm 99% sure it's fake. I'm happy to be proven otherwise. DM me on Twitter or on Instagram if you know that this is not true, that it is not true, that it's fake. But this is the harsh truth, because here I could verify this, but most of the time when write-ups say they are from redacted program, we have just zero tools to verify this. And I actually didn't study this. I don't have time to study every single report like this. I just, while doing the test run for this video, I started to think about it, and I wanted to dive a bit deeper, and that's how I found this out. I hope you don't mind the little off topic. We'll now come back to our case study, and we'll go to the next category, which is data write or modifying data. And we had two reports like this. One of them has been covered on my channel, and not only has it been covered on my channel, it's my most watched video with over 200,000 views, even though I recorded it in 2020 with much worse quality and of pretty much everything apart from the video topic. And this vulnerability was in Zoom local application. It was a local SQL injection, which meant you didn't inject to the Zoom database somewhere in Zoom server, but you injected to the local Zoom client. So the vector of attack was CSRF-like attack with the Zoom MTG link to the meeting, which contained some parameters, and those parameters were vulnerable. The attack itself was also very interesting, with invalid Unicode sequences and things like that. I just love bugs like this. And the impact was you could write to the database in the local client. So the worst thing you could do was modifying settings for the auto joining meeting and joining meetings with the camera turned on. So you could change someone's meetings and invite them to a meeting so they would join straight away. So we could pretty much turn on anyone's camera on the Zoom call wherever you wanted. So it was a really, really interesting bug. One of only two in the case study, which resulted in modifying the data. And after writing the data, we have data read. And surprisingly, I only have 7 reports of SQL injection bugs where hunters actually read data from the database. You will see later what did other reports read, but it was quite rare to see an actual like customer data or a password hash being leaked from the database. One of these that did read the data is this one really nice report of SQL injection in a WordPress plugin, which was only available in the admin panel, which is normally quite bad because if you can access admin panel, it's not really dangerous if you can inject SQL commands because you have all the access anyway, probably. But this SQL injection was chained with cross-site scripting. So you could attack the admin and your cross-site scripting payload would send SQL injection payloads to the backend. So really nice chain. And especially in this case, it was a blind SQL injection. Like most of the SQL injections we have are blind, which means you have to send a lot of payloads. And normally it is not that big of a problem because if you're leaking the data, we don't really care, especially for bug bounty purpose. When you just want to show the injection, we don't care if you use 1,000 or 10,000 or even 20 or 30,000 requests, if there is no strict rate limiting. But with chaining it with JavaScript, it's different because your victim has to stay on the page with the payload for the whole time, which really makes you want to be efficient. In this case, the hunter was able to make more efficient payload and reduced payloads from requests from over 2,000 to 300 to make the attack more likely. Also, if you're interested in the technique to optimize your SQL injection payloads, check out this video I made about a CTF task from Live Overflow from another YouTuber, which I solved, and I really paid attention to the effectiveness of my exploit. I think that's a nice video, and this report is also really nice. Here is the whole payload. You see quite a lot of code for a normal payload, and we can see actual data being leaked, which, as I said, is quite rare in case of these bugs. And it was rewarded $30,000, so quite a nice reward as well. Next, we have RCE with seven reports, and an example of an RCE we have here. Of those 7 reports, as much as 5 were in Microsoft SQL Server, which makes me think that there is something that developers need, because it's the XPCMD shell function that's interesting here, and it's turned off by default. But for some reason, apparently developers need this, and then they either forgot to turn the configuration off, or they actually use this in the production code, or they just don't think that they will have SQL injection, because who would think this way? So if you have an SQL injection in the Microsoft SQL Server, definitely try this out. Here is the whole payload. So we have something like this. We have here master.dbo.xpcmd shell, and then there's the command. And the command was declared earlier, so we just have the ping here, which is good confirmation of the bug, and that's good, because having an RCE just removes any reasonable doubt that you deserve a maximum payout. And now we'll go to 2 most common categories. The second most common was with 27 reports was something that I called no real impact, because here hunters usually only showed that the injection is present and they didn't actually exfiltrate nothing, not even the version, not even the I don't know, the database name. You see a lot of these are time-based, and a lot of them only showed that the response was delayed. So they had the sleep function, like here, sleep 10 means sleep for 10 seconds, so the response is delayed. And it does prove that the SQL injection is there. I'm definitely not saying that there's anything wrong with this, but it just not exfiltrating any data, and it basically works well enough in most cases. It doesn't have to be time-based. For example, here we have the if expression, which changes based on some statement. Here we just have 1 equals 2, which is always false. And based on the response length, the hunter could determine if the condition was true or false. So again, not exfiltrating any data, just showing that the database query was processed. And the average bounty here was $920. But in the most common category, which was reading database metadata, it's $1,500. And so it's 50% increase of the average bounty for pretty much nothing, because this category, reading database metadata, means that the hunters read something which wasn't confidential. Previously, we had the category read data, where you would read customer data, password hash, something like this. The best case scenario, basically, apart from RCEs and everything. And this is the second best. If you, for some reason, are unable to do that, or you don't want to read the data because you're afraid the customer won't like it, you should read some metadata about the database, for example, database name, database version. Here we have one of the very few examples where hunters could see in the response the result of the query. Normally this is not possible, and here just payload from the path was returned here, which is really interesting. I'd like to see the code behind this functionality. So here we have database version, so nothing really sensitive, but enough to prove the SQL injection is there. But sometimes it was really not much. For example, here the hunter extracted the length of the database name, so basically length of the database function call, which was 11, and determined this on some logical condition as well, because there's no time delay here. Here you just have the first digit of the version, and it's basically enough to prove that the injection is there, and yeah, it doesn't feel like much more than I don't know, showing the delay, but we can see on the average bounty that there is it's just better. And if we see like reading real data, looking at the average here doesn't make sense, because there is a mass write-up from Apple which skews the data, but the rest is 30K, 10K, 4.5K, 3K, half K, and $200. So it's definitely more than those ones. So if you have an SQL injection, invest at least this additional time into reading some data, or at least reading some metadata from the database. Don't just report the time delay. As promised, charts of reports and bounties by year. We can see that the number of reports is actually quite consistent. If we take the 2020 year away, I don't know what's the reason behind there being more reports in 2020. And in 2022, we don't see many more reports than in previous years, but we see a lot more bounties being awarded. So this is very interesting. It also shows me that SQL injection is not dead, and I should maybe look for it sometime. But also, as always, relying on disclosed reports is not perfect, because it's only a small portion of all the reports being disclosed. So it's not the perfect statistic, but it's the best we have. If you've learned something new from this small part of the case study, I'm sure that you will enjoy the full version in BBR Premium Archive. The link is in the description. And if you want to see another free video, I suggest you this one about account takeover case study, where I took a look at over $1.3 million worth of bug bounty reports. For now, thank you for watching and goodbye.